Let's do some product rule practice. We said on the other page that an exponential times a sign models a lot of stuff. Here I've got exponential growth times sign rather than exponential decay. That's also important if you got some kind of resonance going on. We can talk about that later. But go ahead and give it a try with the product rule that we just said. Okay, pause the video, do that. Welcome back from pausing. One thing I recommend when doing the product rule, especially when you're first learning, is writing out the generic product rule, f prime g plus f times g prime, and I've written it out here with plenty of space to put things underneath to keep everything in nice neat columns. So I'm thinking of f is e to the t, and sine t is g. So f prime would be e to the t prime times sine t. Oh, one minor hint. Have you noticed that I try to write my t's with a little hook on the bottom to make them easy to tell apart from a plus sign? So I recommend that to you too. And then f is e to the t, and then g prime would be whatever g is prime. And then what's the derivative of e to the t? That's e to the t. And what's the derivative? And then e to the t times what's the derivative of sine t? Cosine t. You could simplify, gather like terms, and get e to the t times sine t plus cosine t, but you don't have to. Let's try it on another one. This one gets a little trickier. 5x plus 11 times 3x plus 19. All of that derivative. So go ahead and write it out and practice it. Pause the video, do that. Okay, welcome back. So again, I'm going to write out f prime g plus f times g prime. And I'm thinking of this part as f and this part is g. So that's 5x plus 11 prime times 3x plus 19 plus 3x plus 19 times, oh, mixed up, that was f. 5x plus 11 times 3x plus 19 prime. Okay, I deliberately made a mistake there. Can you spot it? I need parentheses on that, so I take the derivative of the whole thing, and I need parentheses on the f here, so I'm not just multiplying the 11 by all this stuff, I'm multiplying all of f. Something that lots of people forget. Let's hope you aren't one of them. All right, so what is the derivative of 5x plus 11? Well, that's just derivative of 5x is 5, derivative of 11 is 0. You don't even have to write the plus 0 if you're used to that. You could just write the 5 times 3x plus 19 plus 5x plus 11 times derivative of this is 3. You could even say 3 times 1, derivative of x is 1, but you don't have to. Plus 0, because the derivative of 19 is 0. Again, you could just write the 3 if you're used to doing that kind of stuff. You could simplify that, but that's not the main point. The main point here is to practice the product rule. All right, let's try another big important one that's actually simpler. Let's do 29 times sine t prime. Okay, go ahead and take the derivative. All right, hopefully pause the video. You might have been in the product rule groove and done f prime g plus f g prime. We're thinking of this as f and this is g. So that would be 29 prime times sine t plus 29 times sine t prime. And then let's simplify. What's the derivative of 29? That's 0 times sine t. And then 29, what's the derivative of sine t? It's cosine t. You don't always have to put the parentheses around the t when you're taking a sine or cosine when you're writing it by hand. If you're writing it on Excel or Python or something, you do have to put the parentheses around the t. Okay, let's simplify this. what is 0 times sine t? It's just 0. I can just leave it out. And then I just get 29 times cosine t. So that's one way of doing the problem. Can you think of another way of taking the derivative of 29 times sine of t? Think about that, write it down. Okay. Could we have just used the constant vertical multiplier rule? Now, most books just call it the constant multiplier rule. I like emphasizing that it's a vertical stretch we're applying here, not a horizontal. What would that have given us? Because 29 is an amplitude. It's changing the vertical stretch of the sine. So there we would say 29 times sine t prime is just, well, you copy the 29 and derivative of sine t, and you get 29 times cosine t. So we got the same answer. It turns out you can use either one, but which one is better? Which one saves time? Which one is less likely to make a mistake? I'd say this one is definitely better. So I've had people in classes before say, well, I don't want to have to think about whether I'm going to use the constant multiplier rule or just use the product rule. I just want to use the product rule. And that will get you there, but it's kind of like crawling. It's going to hurt a lot and it's going to take a lot longer, and you're probably going to make a mistake on at least one homework problem or in a pressure situation, a quiz or something. So I really, really strongly recommend learning to use the constant vertical multiplier rule when you can, and not using the product rule for problems like that. All right. So on our next video will be about the quotient rule.